Hello everyone. This talk summarizes the second phase of the research concerning the regional characterization of porosity and permeability testing data within the deep subsurface of the Lockport group. It involves a petrographic assessment of the selected core test intervals in order to address some of the geological controls on Lockport group porosity and permeability trends. The main purpose is to compile and assess the geospatial, statistical, and geological analysis of these core test results. It involves the Salina group, A1 units, and the Lockport group that comprises 4 formations from base to top, including the Gasport, Gold Island, Aramosa, and Guelph formations. Lockport Group is the most significant potable bedrock groundwater resource in southwestern Ontario, among the most significant oil and gas reservoirs and subsurface gas storage units. Recent studies by the OGS reveal that the carbonate in Lockport Group deposited in shallow water, so a revised model is followed here and shown in figure on the right that the Lockport Group represents deposition on the easterly dipping, intermittently and tectonically active carbonate ramp. Data includes a total of 150 core wells and more than 11,000 porosity and permeability datasets. Based on the lithofacies analysis, the study area has been subdivided into 3 broad depositional realms. Area 1 is where the pinnacle structures occur. Area 2 represents the mid to outer carbonate ramp where karstification is rare and pinnacle structure is absent. Area 3 represents the inner to middle ramp settings in the northwest to southeast direction. As marked by the yellow dashed line, the northwestern end of the Area 3 is dominated by platform interior deposits, whereas in southeastern Area 3, local reef mount facies developed near the platform interior edge. Now let's take a look at the porosity and the permeability data distribution in each area by formation. Data has been grouped by areas, including the interpinnacle and the pinnacle structures in Area 1 and northwest and southeast part of Area 3. We have limited data in Gasport formation in Area 3 that only 2 wells are in the database. Within Area 1, in the pinnacle structures, the Gasport is relatively less porous and less permeable than those in interpinnacle areas, as we do see highly permeable examples where the karstic conduits penetrate into Gasport formation in interpinnacle regions. The Gold Island Formation is relatively porous in Area 1 and in southeastern Area 3 that form as the lower part of the oil and gas pools. It is similar to Gasport Formation that the permeable intervals do occur where the karstification penetrates into the Gold Island Formation. In Area 3, it corresponds well with its thickening in gas pools where the reef mount facies developed. Guelph Formation is the best studied one in Lockport Group. Similar to Gold Island Formation, it is porous in pinnacles and gas pools in the southeastern Area 3. Within the interpinnacle regions, Guelph Formation is relatively thin and porous with variable permeability. In Area 3, the porosity and the permeability increase southeasterly, as you can see the change of dot size in both maps. So this is in response to the generally thickening of Lockport and the occurrence of bioherns. The Salina group A1 carbonate is preferably deposited on the lowlands on top of the Guelph Formation. It is relatively thin over the pinnacle structures and thicker in the interpinnacle regions. It is relatively dense in the interpinnacle regions, though having a karstic and a porous top below the A2 evaporites. It is porous in pinnacle structures and the southwestern Area 3 that forms the top of the oil and gas pools. So in summary, the porosity and the permeability variations of Lockport group correlate well with the stratigraphic architecture in pinnacle structure-bearing region. In the pinnacle structures, where the Lockport group is thickest, the average porosity and permeability values are highest, illustrated by the data percentile distribution charts. In interpinnacle region, the karstic penetration enhanced the overall porosity and permeability of the Lockport. And in Area 3, the regional porosity and permeability has a general increasing trend southeasterly that corresponds with the local thickening of strata units and occurrence of reef mount facies in Gasport and Gold Island formations near the edge of the platform interior. From this slide, we'll display core and thin section examples that help illustrate the geological controls concerning the formation and destruction of porosity. These three wells are examples from the terminus pool in pinnacle structure in Area 1. Guelph formation possesses the modic porosity, intercrystalline porosity, and irregular vugs. Various karstic intervals have also developed, indicated by the recrystalline features. In the A1 carbonate, leaching-enhanced fenestral vugs are very common that are parallel to the bedding planes and forms the uppermost part of the reservoir. Although the dolomitized and clotted appearance have altered some key depositional features, the microporosity are well observed in thin sections. The Salina A1 carbonate has irregular intercrystalline porosity above the algal mats. Modic porosity and intercrystalline porosity among the anhedral and euhedral dolomite crystals are well developed in the Guelph formation, although reduced by the dolomite cementation to some degree. Gold Island formation has large irregular vugs that have been enhanced by diagenetic dissolution. Within the interpinnacle karst area, there is a pronounced thinning of all formations in Lockport group into 20 meters. Dissolution-enhanced fenestral vugs are very common in the A1 carbonate, and highly karstic features occur in the Guelph formation, including karst rubbles, karstic conduits, and recrystallized cements shown in the photo, which means the whole Guelph formation has been dissolved or removed, resulting in a thin unit. Salina A1 carbonate is dominated in algalaminites and palloids. The horizontal intercrystalline porosity usually is controlled by the growth of algal mats, and intraparticle porosity may form within the palloids. Intercrystalline porosity and microvugs in Guelph formation are very common porosity types. Within the Gold Island formation, the irregular vugs have been partly plugged by the euhedral dolomites crystals. In summary, all the formations in this area has been dolomitized except for the A1 carbonate in the interpinnacle region. The major porosity types have been controlled mainly by the diagenetic processes. The overall porosity has been enhanced by dissolution, karstification, and dolomitization, and reduced by cementation. Within the pinnacle structures, karstic intervals do occur within the Guelph formation, and in the interpinnacle karst region, the karstic conduits and karst rubble dominate the Guelph formation that enhance the overall porosity of this unit. As we move easterly into the northwestern Area 3, no oil and gas shows occur in the Lockport group. These dolstones maintain the lowest average porosity and permeability in southern Ontario. Modic and intercrystalline porosity dominate the Lockport group, and the fenestral vugs developed in the algal mudstones of A1 carbonate. Matrix of these dolstones is highly bioturbated and well cemented. Anhedral and euhedral crystals of dolomites have replaced the depositional calcites, giving these dolstones a coarsely crystalline look. Dolomites are recrystallized and coarsening in this area. Vugs in Guelph Formation are reduced by dolomite growth or cementation that is possible formed in late diagenetic stage. Dolstones show clotted and pyloidal fabrics in Gold Island Formation and Gasport formations that are also well cemented by euhedral dolomites. Stylolites formed during the deep burial may have controlled the formational water flow for dolomite recrystallization during the late diagenetic stage. So tracing southwestward into Area 3 near the edge of the interior of Carbonate ramp, the thickness of the Lockport is regionally consistent with some localized thickening recorded in small areas along Lake Erie where the natural gas pools have formed. In this Tilbury gas pool, occurrence of the stromatoporoid coral skeletal boundstones in Gold Island Formation has formed the localized reef mounting facies that may have accounted for the enhanced porosity. Karstic conduits near the top of Gold Island Formation has occurred, while the vugs and modic porosity dominate the Guelph Formation. In general, in this area, dolomites are finely crystalline. Vugs and modic porosity are most common in all the formations in Lockport group. In Area 3, the regional porosity and permeability distribution is controlled by a variety of factors, including the lithofacies and diagenetic processes. In Northwestern Area 3, the porosity has been highly reduced by dolomite recrystallization and cementation, and in Southeastern Area 3, the occurrence of biohermal facies has increased the formational thickness and the overall porosity. So in these carbonates, the primary porosity has been altered by cementation and dolomitization. And the porosity types in key porous and permeable intervals are all secondary in origin, including the intercrystalline pores, dissolution-enhanced vugs, and modic porosity. The porosity is enhanced by diagenetic processes like karstification, carbonate dissolution, and possible cementation dissolution. The occurrence of karstic intervals, evidenced by those karst rubbles and karstic conduits, are key to enhance the overall porosity by controlling the diagenetic water flow pathways. And cementation compaction may have reduced the overall porosity. Thank you for listening and welcome to ask questions.